In this video, we are going to discuss about the introduction of operational amplifier. The name Op Amp comes from the operational amplifier. We usually call Op Amp as the short name. What it does, it amplifies the input signal as per the designed parameters. Like whatever you have designed to amplify the inputs of the amplifier, it will do the same things. An op amp is an integrated circuit that uses external voltage to amplify the input through a very high gain. Op amp performs a variety of operations such as it will do amplifications, we can have additions, we can have subtractions, we can have differentiations and integrations. Op amp is a multi-stage amplifier which uses a number of differential amplifier stages interconnected to each other in a complicated manner. These internal differential amplifier uses bipolar junction transistors or field effect transistors as an amplifying device. It also has some golden rules which we need to remember. The first one is op amp has an infinite open loop gain, which is a very good advantage of the op amp. The second one is the input impedance is infinite while the output impedance is zero. Ideally, we consider these conditions. So which is also a very good, because if the input impedance is infinite, no current will flow into the inverting or the non-inverting input of the op amp. In a circuit with negative feedback, the output of an op amp will try to adjust its output so that the voltage difference between its inverting and non-inverting input is zero. Like we call V positive as the non-inverting input and V negative as the inverting input. Why integrated technology? So that is another question. The need for the construction of inexpensive devices. Also, we need a reliable devices, and there is a demand of digital systems because the miniaturization of the devices demands everywhere. So that is why digital systems has to be manufactured. For example, if you want to transmit a signal from destination A to destination B, so while passing through intermediary stage, what does those intermediary stage are the multi-stage amplifier, because when the signal propagate through a certain distance, the signal attenuates its strength. And then what does the amplifier will do? The amplifier will amplify those signal again and then they transmit. Like if you see this diagram, so this is a Q1, so it means that the transistor 1, so which is connected through a coupling capacitor to secondary transistors, and we also have a bypass capacitors. So this is a two-stage amplifier, but if the situation keep going, then the sizes keep increasing. In a multi-stage amplifier, many BJTs, as we have seen, or FETs are connected through coupling capacitors, bypass capacitors and resistors. Since the number of stages increase, the size will also be increased, which causes many issues. Like if these capacitors and bypass capacitors are increased, the reliability of the device will be decreased. And also it increases the power consumptions, and if the number of components keep increasing, then the cost of the device will also increase. So these are the few disadvantages of multi-stage amplifier. So that is why we need integrated technology. So to overcome these issues that I have discussed, IC's technology has allowed the construction of inexpensive devices, and also it increased the reliability of the device, and digital systems are developed. For example, amplifiers with very stable characteristics is also developed. And what is integrated circuits? An IC is a group of transistors, diodes, resistors and capacitors wired together on a very small substrate, which is usually called wafer. And what are its advantages? So it decreases in size, a reduction in weight, power consumption and cost as well. The other thing is that it increases in reliability with certain proportional. And we have many application of ICs. ICs has gained interest in every field of technology. First one is automotive industries. You can see that the ICs keep increasing, how automotive industries is moving towards autonomous cars, computerized cars. Now everywhere people are talking about the autonomous cars. Medical technologies. So we have seen that the doctors sitting far away from their locations, and they are operating the patients. They are doing different surgeries from far locations. Entertainments, you can see that the entertainment industry has also increased in a number of different like the decrease in bandwidth, increase in quality, Q factor, all these things. And the business industries as well. So business industry is also moving toward e-commerce and all these things. We have different types of ICs. First one is analog IC, so which is used in radio, TV, stereo amplifier, voltage regulators, signal generators, filters, industrial measurements and controls. The second type is digital ICs, which is used in computers, calculators, digital watches, communications, switching, digital instruments and industrial control systems. Like if you see the analog, so this type of waveform of analog devices is known as the analog waveform, which is continuous in time. But if you see the digital, so that is a square waveform. So we have different fabrication techniques. The first one is the monolithic, where ICs are built on a substrate of silicon, where transistors, resistors and capacitors rarely used are produced by a diffusion process. Isolation between transistor relies on a reverse bias junction between the transistors and the silicon substrate. So this technique is very time consuming and expensive, but large number of ICs can be produced simultaneously. This will reduce the cost per chip. Like if a mass quantity of ICs is produced, then this will reduce the cost, which is the main advantage. But it has many disadvantages as well. Like capacitors are very difficult to produce using the diffusion process. Tuning the ICs by adjusting internal resistors is very demanding, but it is very difficult in the monolithic process. Transistors isolation is also not very adequate. So to overcome the limitations of monolithic techniques, hybrid techniques is used. In this technique, discrete resistors, capacitors, diodes, transistors, and even monolithic ICs are placed on a ceramic wafer and then interconnected. It has many advantages. So the first one is excellent isolation. Hybrid technique has many advantages. The first one is the excellent isolation. And excellent isolation allows the use of any devices to be connected. The other advantage is easy to customize tuning before encasing. If you like the video, press the like button and subscribe the channel for more such informative videos.